Hi, I'm John Will, and I oversee business operations.
Hi, I'm Michael Vogel, and I'm in charge of business development, and we are with REhnu Incorporated. We focus the sun in order to create electricity and heat in a compact, simple solution.
Our long-term goal is to be able to bring power to the 1.2 billion people in the world that don't have power, and this can be done either in off-grid or through working with utilities in a much larger scale environment.
So, what do solar panels, concert halls, commercial buildings, and telescopes all have in common? Well, I'll tell you. It's bent glass. Hi, we're with REhnu Incorporated, and we use bent glass to take traditional solar panels and concentrate them. Think of it as solar energy 2.0. When we first went through the Thryve program, we were focused mainly on the solar aspect of our business. But as we went through the classes, we learned that we are so much more than just a solar company. Our solar system is so innovative that just one component, the curved glass, has numerous potential to be used in multiple applications. So what do I mean by that? So there's two types of curved glass. This is an example of single-axis curved glass. This table looks crazy and complicated, but in reality, it's pretty simple to make because it's bent only in one direction. Whereas dual axis or bent glass is bent in the X direction as well as the Y direction. Bent glass is complicated, it's expensive, and because of that, until now, it is rarely done. So this man works in the automotive industry. This fixture has been designed for this specific windshield. It's designed for high volume, and it's cost effective if you're making many of the similar curved glass, but it's extremely expensive if you're making just one. And so at REhnu, we have the solution to this problem. We've designed a patented computer-controlled mold that allows us to create custom-shaped glass quickly and efficiently. And so how does it work? So this is a cutaway view of the mold. Here, the cells are connected to the computer, and this is what a close-up of what one of the individual hexagon cells looks like. So the entire mold lives inside of an oven, and the flat glass is inserted in the oven on top of the mold. The model is uploaded to our software, and then in just 4 minutes, the cells will have moved to the correct position to match the shape of the mold. In this example, these 4 have moved up to match the curve. And so just 4 hours later, the glass will have heated up, melted, conformed to the shape of the mold, and cooled to create a custom shape of curved glass. And so I've described how REhnu creates this custom shaped glass, and now John will describe why it matters so much.
In a traditional process of producing shaped or molded glass, the investment is about $50,000 for the cost of the tooling, and the time to produce that tool will take 3 to 4 months. If an application exists where there are multiple needs for custom tools, the first tool would be $50,000, the second tool $100,000, third $150,000, $200,000. I think you get the idea. It becomes very expensive and takes quite a lot of time. So our solution is at least 90% less expensive because there is not the investment that's needed in the actual mold. And you can get a working prototype in hours or conservatively in just days. So here's an example of the type of shape that would come off of a computer-controlled mold that we've produced. The glass business or glass industry in the US is a $26 billion industry. And shaped glass or special glass is about $4.6 billion. With these numbers, we realized that we could easily have a $25 or $50 million business with just a small market share. During our research, we really found that there was a lot of competition out there. But most of the competition is in single-axis shaped glass. Now, there are companies that can do dual-axis shaping. However, they need to invest in the mold, just like anyone else that would want to do that is. Except our competitive advantage is that we don't need to do that, and we can do it in quite a lot less time. So we feel that we have a very disruptive technology. And I make the analogy that it's very similar to 3D printing. So 20 years ago, 3D printing wasn't very common. I mean, it was just becoming common in the last few years. And now if you look around, there's so many applications that people never even dreamed about what 3D printing could be used for. So we believe that there are applications yet to be discovered in forming and shaping glass that because of the cost of the mold and the complexity just haven't been applied. So our go-to-market strategy is early adopters, research institutes, and looking for rapid prototype opportunities. One of the things, because we've just been starting our market research, is that we believe that in the construction and architectural areas, there's great opportunity. In fact, what we're doing is customer interviews, and we've spoken with a local architectural company who's very excited about our application and believes there's a lot of potential, either in architectural indoors, or outside in the glass area. And furthermore, in automotive and transport, there's a lot of opportunities as well. We've seen it in yachts and different custom special applications. So, as Michael mentioned, our technology is patented. Dr. Roger Angel and Dr. Thomas Stalcup, and I'm pleased to say that Dr. Stalcup is here tonight to see our presentation. So both these gentlemen, as well as Dr. Peter Strittmatter, are part of our REhnu team. And the three of the gentlemen combined have over 75 years of experience in shaping and forming glass. And many of you know probably that Dr. Roger Angel, in 1980, started the Mirror Lab. So very, very highly technical team with very unique technology that's been generated at REhnu. We also have partners outside. We're working very closely with the University of Arizona. As you know, our founders are based from the U of A, and we have lots of opportunities to use and work with technical experts there, as well as in the model shops to help, which was very helpful in developing our first prototype. In addition, in the commercial area, we're working with Stanford Research Institute. Been very helpful in us developing this technology. So REhnu is a very technical company, developed very interesting technology in solar, and now we've done that in glass. Disruptive technology, we believe, there as well. So what I'm asking the audience for tonight is, if you know of any applications, or if you know people and you think about it, hey, this would be very neat, please come talk to Michael or I, or just contact us at REhnu. We're just local in town, and we love to hear from you. Thank you very much.